Good morning, ladies and gentlemen, GRCA fellows, honorary members, full members, and members. I extend my warmest welcome to all of you here today after many years, as we will be sharing an insight for maturity topic of GRC early age. In the course of this presentation, we will explore the techniques and instruments employed to observe and improve the maturity of GRC material. So, to enhance the quality of our GRC manufacturing, we have contemplated the idea of predicting the early strength development of our materials. By doing so, we aim to create a more durable material and tailor our manufacturing process. Let us begin by examining the definition of the problem. One of the primary challenges in GRC material is the occurrence of shrinkage and getting the high temperatures. Additionally, high temperatures pose another hurdle as they can lead to thermal expansion and contraction, potentially causing cracks and deformation. To address these challenges, a well-structured time plan of production is essential. Efficient production processes, including mixing, molding, and curing, must be meticulously planned and executed. Before getting further into detail, we will look to the alternatives for the test of determining concrete strengths. Then we will get a small remaining slide for the hydration process, and which is playing vital role in the development. Moving on, we will explore the basics of the early age maturity in the context of GRC material. Maturity refers to the cumulative effect of time and temperature, so that we can make informed decisions regarding the demolding, handling of the GRC elements, and also selection of the mold types as well. In the pursuit of advancing the maturity, a developed method has been introduced, and we will be sharing with you that method. A systematic approach to assessing and monitoring the maturity of GRC material throughout its production and curing phases. By collecting data and analyzing key indicators, we gain valuable insight into the material's progress and ensure its quality and reliability. Moreover, a maturity device has been designed specifically for GRC. This device enables real-time monitoring of the maturity, allowing for precise control during the casting and application process. The next item will be our findings. In conclusion, the maturity of GRC material encompasses various aspects that impact its performance and durability. Through continued research and innovation, we can unlock the full potential of GRC and ensure its widespread utilization in the market. So, if we focus on the definition of the problem, full-time monitoring of early age strength in not only compressive strength, also in flexural strength is having a vital role. Firstly, shrinkage, especially in large size and complex shapes, can create very complex stresses and can cause unwanted cracks, bending, or distortion in the curing process or in the product during lifting. High temperatures may lead to higher shrinkage values. Control of high temperatures by changing the mix designs, so we can control the shrinkage as well. We need to take the necessary precautions by monitoring this maturity values. Based on this follow-up, making a time plan for production is possible. When will be the embedded parts to be placed? When to finish the castings? When the molds be loosed or removed? When to demold the material? Or when to lift it? Therefore, the strength and shrinkage of GRC shall be accurately estimated and managed by manufacturers. It is important to determine the internal structures and mechanical behavior of cementitious materials during the setting period. Before getting deeper into the subject, let's see alternative methods to determine concrete strength during non-destructive and destructive methods. And most of them are destructive. Destructives are focusing only mainly about the compressive strength values. But since GRC material has been widely used for architectural purposes, so we have to select a method which is non-destructive. But at the same time, what we show right now is mainly about the compressive strength values, predicting the compressive strength values. But in our sense, we have to focus at the same time for fractional stresses as well. So we have to have a tool to get the knowledge and influence the compressive and flexural strengths at the same time. So we will come to that subject, how we can conclude a data which refers to both strengths at the same time. Let's give a small hydration process. We all know that GRC, by the time, due to the exothermic reaction of the cement and water, we receive strength gain on GRC and also heat increase occurs. So react with each other, cement, water, so that all the materials in the mixtures are bonded. So in principle, we have to focus on our mix designs in controlling on this shrinkage process or heat increase process, so that we can estimate also concrete strength based former values, former tests we have done. And time and temperature have an important place among the factors that affect the strength of the concrete. In addition to these factors, such as water-cement ratio, factors such as water-cement ratio, cement type, amount, mold type and properties, ambient humidity and temperature, and also pozzolanic materials to be used, have effects on strength. The maturity degree of concrete is defined as keeping secondary factors constant and accepting time and temperature, as you may see on this graph, the below side of its, let's say, of this maturity phenomenon. So accepting time and temperature as the only variables. The concretes with the same maturity have got the same properties. Therefore, by measuring the time and temperature profile of the GRC composition, we can guess about the compressive and flexural values of that mix. Studies on maturity have been conducting since the beginning of the concrete production, but we applied these studies specifically onto GRC, very, let's say, fiber composite application and also thin elements, which until this moment, all the maturity data has been got for the normal concrete works, not a fibrous composition. If we dig into basics of maturity, let's say I'll share two different equations actually. One of them we have used, and we will talk about that later. There are two widely used methods to calculate the maturity index from the measured temperature history of the concrete. The first method is known as the Nurse-Saul. Big M refers to maturity value, and big T refers to temperature, and small t refers to time. So we do have a maturity value and a formula between the delta T times the temperature changes. And on the second de Vries function, let's say, we do have a C factor, which corresponds to coefficient related to cement. It should be determined by the calibration studies, which we will show. And I will detailedly mention about the calibration process in the coming slide. And this big T refers again to temperature. But still we don't see the F, the fiber composition, which we need to add also into equation as well. So based on the theory of the hydration reaction, there is a relationship between age, early age, and compressive strength gain. Also, there is a relationship between maturity and age, so they can be combined together. Temperature values can be converted into maturity values with time-dependent functions. The maturity value is converted into bending and compressive strength values. In the current study, as an example, the temperature, shrinkage, maturity, and strength values of the full-size GRC panel were examined, and these results were explained with graphics. The temperature values were measured with the help of a key-type thermocouple placed into the concrete. I'll show you a different image as well afterwards. These values were transformed into a maturity index by using this de Vries-weighted maturity function. To obtain the C values calibration, which referred from the cement part, study is conducted. To define the C value, we took 6 samples from the mixture, from each mixture. Then we placed them into hot water whose temperature is known for certain time intervals. Each specimen was kept at different temperatures for different time period. At the end of this process, we correlate the strength results of each specimen with their maturity, which is obtained by using this equation. The only parameter that we don't know was actually the C factor. And we have put regularly from, let's say, between 1 and 2 in small intervals such as 1.05, 1.1, 1.15, and then we targeted the best available C coefficient in order to use that in general equations. And moreover, at the same time, we collected with the same mix design a shrinkage value by using a 1 meter shrinkage, 1 meter in length and width, 60 by 100 millimeter cross section are used for recording the length changes measured along the central axis of the specimen using an inductive sensor leaning against the movable head of the mold. So all measurements were performed under laboratory conditions. Then, at certain time intervals, we determined the compressive and flexural strength of these compositions by conductive destructive tests. But for doing that in a daily environment, we cannot make each day these tests. Therefore, we are trying to get the best knowledge from that mix design. And as you may see from this screen, there are 2 main equations popping up from these test results, actually, which is one for the flexural, one for the compressive values, and the calculated maturity index. Based on the relation these equations are proposed, the first equation can be used, the flexural, by following its temperature history. And this small f here on that side, the big F, let's put it that way, indicates for the fiber ratio. The second equation is for the compressive strength value. Okay. And then to provide a more precise and healthy measurement values for the strength of the materials, we developed a device, and this device can be seen from this picture, printed in our 3D printing machine, etc. At least one of the temperature sensor is placed into the element, and the temperature, and according to the size of the piece or the complexity, you may use more than one items actually. And this device can collect the maturity value and also the temperature. There is a temperature sensor inside of it. The number of sensors should be increased in case of complexity. The measured temperature data is transmitted to the maturity measuring device in communication with the temperature sensor. By the interface into maturity measuring device, maturity, flexural strength, and compressive strength of the element are estimated. So you may see in this graph the maturity line pops out in the time effect. Here is the x-axis is the time, and the y-axis is the maturity value. Whereas we can read the strength values from the right y-axis. We can see from this graph, once the maturity continues to increase, we can see that the flexural strength on what time is getting more, and also on the compressive strength to judge when to demold the material. Maybe we are not using in our daily production that detailed demolding. We decide into doing something, let's say keep the material on the 24th hour from the mold, but in that sense we may control the environment of what we are deciding, and also by changing the ambient temperatures as well. So then we have collected for making you an obvious attraction. When the graphics are examined, it is seen that the concrete heats up during the setting stage and begins to shrink as a result of this heating. It has also been found that GRC resists some shrinkage at maximum temperature. In this way, we ensure that many processes in the production process, such as loosening times of the anchors, determination of the demolding times, and taking necessary precautions of using different kind of mold types according to the needed mix designs, are very important to be read. If I look to this graph, let's read together with you. We can search for a maturity value. You can read that with a green line. And once there are two different compositions. One is our, let's say, our own GRC mix design. One is a regular type of GRC without using any pozzolanic additions and using SEM 152.5 cement. And you may read the difference between actually our both mix designs, but let's keep on that track. We can just look very detailedly when the shrinkage starts and when the heat gets on the highest ground. So if we can look detailedly on each mix design and also on each material, we can decide which type of mold to be used, when to demold the material. So to wrap up, the maturity functions are for the estimation, as I have mentioned, on the compressive until now, but right now with our literature actually we are capable of delivering the compressive and flexural at the same time with that maturity index. And in this study, a method and device has been developed that can instantly calculate maturity values, and which is the basic design values actually, and considering different fiber amounts and lengths as well. The maturity method provides information about the time and temperature relationship of concrete products, and health monitoring of panels can be done by using this method. According to this follow-up, the necessary precautions can be taken immediately. And also, based on this proposed equations, a device is developed to monitor the health of the GRC panels. And thank you for listening. And